In this video, I'm going to show you how to insert node in a binary search tree. Here's the pseudocode, and we are going to start off by setting up our insert method. It will have taken a value as an argument. So let's go to our pseudocode. So the first step is we're going to create a new node. Okay, so I'm going to do const new node equals new node, and this will take value as an argument. Next step, if root node doesn't exist, then make newly created node to be the root node. Okay, so if not this dot root, then I'm going to say this dot root equals the newly created node, and then we're going to return this, or return the tree, and that was the next step here, just return the tree. Next, set root node to be variable current. Okay, so if we pass this if statement, that means that a root node already exists. So we are going to set up a variable called current and make that equal to this dot root. Next, we're going to start a loop, and this will be a while loop, and it will run as long as we will set this to true, so it will continue to run as long as that is true. As we enter this loop, we're going to start off by a condition: if value equals current node's value, then return undefined. So that statement is pretty much saying if we already have the value that was passed in as an argument, that means we already have that value existing within our tree. So just return undefined. So if value is equal to current dot value, just return undefined. Next, if value is less than the current node's value, then we are going to enter this block of code, and then it has else if value is greater than the current node's value, we're going to enter another block of code. So the way we're going to do that is if value is less than the current value, then enter this block of code. Else if the value is greater than current dot value, then enter this block of code. Okay, so if we enter this first block of code here of our if statement, we arrive here. So we have another if statement saying if current node doesn't have a left child, then insert the new node here and return the tree. So if the current node doesn't have a left child, then we can just insert our newly created node here. So if not current dot left, then make the current dot left equal to the new node, and we just want to return the tree. Next, we're here, and it says set the current to be the current left. Set the current to be the current left's child. So we are going to set current to be current.left. So now as we go back to restart the loop, the current variable will have a new value of the current's left child right here. And so now here inside of else if, it's pretty much going to be identical to here, except we're changing the values from left to right. So we can look at this and say here in our else if value is greater than the current node's value, then here if current node doesn't have a right child, okay, so it's the same thing as this here, but we are saying if not current dot right, then just make the current dot right equal to the new node and return the tree. Okay. So now that we completed that, we have to set the current to be the current right child. So we can go ahead and copy this here and paste that right over here and change this from left to right. And this is it. This is our insert method. Now let's go ahead and test this out. So I will start by creating a new binary search tree and call it tree binary search tree. Doesn't take any arguments. And I will use our insert method to create this tree structure that I have right over here. Our tree that I'm trying to duplicate is this right here. So what I'm going to have to insert 1, 2, 3, 4, 5, a total of 5 nodes. So the way I'm going to do that is tree.insert, and the first one I'm going to do 10, and I'm going to go here, copy and paste. Mistake here. All right, paste. Have total 5 of them, and the next one after 10 I will do 7, and then I'm going to do 12 here, and this one is 3, and then the final one is 9. And then right below I'm going to do a console log of our tree. So I want to see this in the console. And if I go ahead, I'm going to expand this view here, our console, and I'm going to run class constructor binary search tree cannot be invoked with new. Oh, my mistake. Of course, we're instantiating a new object, so we have to add the new keyword in front of it. So now if I rerun the snippet here, you can see in the console I have a binary search tree. As the root, I have, so that would be here, right here. And note all of these individually are nodes. All right, so the very top of our node right here has the value of 10. And if I move now to the left here, if I expand this root node here and look here to the left, I have a value of 7. And to the right of our node with 10, you see the right, it has value 12. So if we consider now going from 10 to 7, let's go ahead. So let's go to the left node, and you can see here that this node with 7 has a left child and a right child, which for the left it's 3 here, and for the right, it's 9 right here. So we had successfully built out this tree right here, and we can see that our insert method is functioning correctly. So we were able to learn how to insert a node in a binary search tree.